Hi, hello everyone. Welcome to VisionIGCSE. It's classes for IGCSE, AS and A Level student around the globe. Today we have to discuss one of the challenging and interesting question from Pure Mathematics 1, February, March 2023, means this year paper actually, and our regular batches for GCSE, IGCSE, AS, A Level students are going on. Suppose if you want to connect with us, I have left the contact in the description box. You can straight away connect to us for classes. Question number 10 says that at a point 4, -1 on the curve, gradient of the curve is -3 by 2. So dy by dx is equal to -3 by 2 is given. It is given that dy by dx is equal to x raised to -1 by 2 plus k, where k is constant. We have to find out firstly, means show the k is equal to -2. Here dy by dx, we know that it's a -3 by 2, which is equal to x. Take this point, okay, 4, -1. So 4 raised to -1 by 2 plus k. So 4 raised to -1 by 2 means it's a just 1 upon 2. You can put in the calciums, calculate. So -1 upon 2, 3 upon 2 is equal to 1 upon 2 plus k. And if you solve this one, k is equal to -3 by 2 minus 1 by 2 means basically k is equal to -2. Fine, that's it. Alright, then find the equation of the curve. So here we have a dy by dx is equal to x raised to -1 by 2 plus k, right? You can transfer firstly dy by dx to the right hand side. So dy is equal to x raised to -1 by 2 plus k. Here dx, take the integration on the both side plus c. Fine. So it will be y is equal to x raised to -1 by 2 plus 1 means it's just a 1 by 2 upon 1 by 2. Okay. Plus k times x. K already we know value of k, so you can put out here k value, which is -2. So -2x plus c, and you can put out the point 0.4, -1 here. Okay, so -1 is equal to 4 raised to 1 by 2 upon 1 by 2 minus 2 times x is 4 plus c. You can calculate this whole thing. So it will be -1 is equal to 2 times 2 minus 8 plus c, right? So it will be basically -1 plus 4 is equal to c, and c you will get 3. Fine. So from this equation you can write as a y is equal to 2 times x raised to 1 by 2 minus 2x plus 3. This is the equation of a curve. Getting it? Then find the coordinate of a stationary point. So to find out coordinate of a stationary point, we have to take the derivative basically, right? And derivative means derivative dy by dx is equal to, straight away we have to compare 0. Okay, and dy by dx we know that it is given here x raised to -1 by 2 plus k. K is -2 means here x raised to -1 by 2 minus 2 is equal to 0. X raised to -1 by 2 is equal to 2. You can square on both sides. So it means here x raised to 1 by 2 bracket square is equal to 2 square, means it's a 1 upon x is equal to 4, means x is equal to 1 upon 4. You will get the value. Fine. And we have to find out stationary point. Even we have to find out value of y as well. So we got the equation of a curve. Put this x is equal to 1 by 4 in the equation of a curve. So equation of curve is y is equal to 2x raised to 1 by 2 minus 2x plus 3. Put here 1 by 4 raised to 1 by 2 minus 2 times 1 by 4 plus 3. So it will be basically 1 by 4 raised to 1 by 2 means square root of 1 by 4 is just a 1 by 2. 2 to get cancelled out, and here minus 1 by 2 plus 3. And you will get value around 1 minus 1 by 2 is 1/2 plus 3 means 3.5 is basically y. So you will get the point as a 1 by 4, 3, 1 by 2. That's it. That's a point actually. 1 by 4, 3, 1 by 2. Then determine the nature of this stationary point. So nature, either maximum or minimum. How we can identify? We can take the double derivative and compare whether it is less than 0 or greater than 0. So we have a dy by dx which is equal to x raised to -1 by 2 minus 2, right? Then if you take the double derivative, it will be -1 upon 2 x raised to -3 by 2. fine. You have to use x raised to n formula. So of course, if you put here x value to 1 by 4 and here you have a negative sign, right? So negative sign means this is even less than 0. Less than 0 means this given point is maximum point. Okay, this is how means you have to step by step answer these questions. Yes, that's it. I hope you like this video. Share and subscribe to our channel as well. Thank you.